Okay, so in this video, we'll start looking at data frames. So we'll look at different ways of generating data frames or kind of opening a data frames first. The main way we'll do that is to make it open from a CSV file. Okay, so you need to make sure these are the packages that are included in any code that you work with data frames. The CSV package, data frames package, data frames meta, and this statistic package listed here. Okay, so this is a common one way actually to um, open a CSV file and load the content of the CSV file to a data frame. So the CSV file that we're looking at here is basically, let me close this. There's this one. So it has two columns, the assignment scores and the exam scores of students. And so we want to load this to our code and load it as a data frame at the time of loading itself. So this is all syntax here in Julia. So csv.file. So we're calling the file method in the CSV package and passing the file name. So this file, I'm assuming, is in the same directory in which I'll be running my Julia code. So you could also do the same thing. Otherwise, you'll have to pass a path to the file. So either way is fine. So make sure the file, the Excel file is saved as a .csv extension. When you save this, you type this and make sure you save as a CSV file. Okay, and so once we load it like this, csv.file, and then you pass this whole thing to a data frame method. It's like a constructor for the data frame, like an object-oriented programming. Now you could create on the left-hand side a data frame object, df. Okay, it's just user-defined object. You could name it anything you want. I just name it as df for data frame. So the first thing we will do is call the describe method and pass the data frame object as the argument to it. So let's see what it's going to print. Now again, make sure you're running you have already run the import packages file that I always reiterate. So the import packages file. So if it is not installed, these packages will be installed when you run it for the first time. If it's already installed, it will check for any update and it will install the updates if anything is there, if anything out there. Okay, so if you run this program, so I call it as data frame underscore matrix because I want to show the interplay between matrix and data frame, how you can create one from the other. So again, I have not been running it for a while, so it takes some time to start the Julia. Okay, it's running. Okay, so the describe method basically does this. Let me print a line here. Okay, so it's going to print the kind of statistics about the CSV file and the data loaded to the data frame. So there are two variables here, the assignment and the exam. So these are the names of the columns. So they are taken from the CSV file. And so AST and exam are from the CSV file. And basically the data is numerical data. So that's easier to look at later. We'll look at some string data as well. So it will first display the mean value of the values in each column. So for the assignment scores, the mean value of these 11 numbers is like 32 point something. Same thing with exam. Then the minimum of these scores in the assignment is 20.4, with exam is 15.5. The median, so the median is like, so if you sort all these assignment scores, you take the middle value among the 11 numbers. So that's the median. And then the maximum. And then if there are any missing data in any of the rows, that will be also how many rows are reporting missing data. And then the data type of the columns here. So both the columns here are of float 64 because they have a decimal digit. So they are read as float values automatically into the data frame. Then you could create a matrix out of this data frame. So that's a very important construct that's available in Julia. So you don't have to do anything else. So you can just, so again, this matrix is like a class name. You can pass it as call it as a constructor and pass the data frame object itself as the argument. So it's going to generate a matrix, and on the left hand side, this matrix is just user defined name. So you could name it anything you want. Now, when you call the size method on this matrix, which we already saw in the matrix videos, it's going to return the number of rows and number of columns in that matrix. So you can capture that as a tuple, and it's up to us to name these variables however we want. So I name it as n rows and n cols. So here I just go over the matrix and I'm printing row wise. So you could call the print matrix method that we used to have, and that's what I think the same thing is doing. So it goes through each row, and then in each row it goes through each column and prints the matrix value at that row index and column index in a blank space. And then once done with that row, it prints a new line and then goes to the next row. So that's what we see here being printed. The uh, assignment and exam scores printed as a matrix. Okay, so now, um, so what I'm going to show is using the matrix, we can now create a data frame. So earlier, we first loaded the CSV file as to a data frame, as a data frame object. And then from the data frame, we saw how to generate a matrix out of it. Now, using the matrix, how to create a data frame. So I'm calling it as a second data frame that I'm going to create. Now, this is kind of like the syntax for that. So the data frame is the constructor here, the class name, and then you can pass the matrix that you just have create here as the argument. Now, you could just pass the matrix. If you don't pass the column names, it will you could pass auto if you want. If you put auto here, Julia will choose the column names and so on. Typically, it will say example one, example two, or something. It's up to the Julia environment. But typically, it's very recommended that you pass a vector of column names. So we know that this matrix has two columns, and the first column is assignments, and the second column is exams. So since this file has a column name says ASG and exam, I'm making it a little different. I'm calling this column as assignments and this column as exams. So those are two strings. It's a string vector, the column names, and it's passed as an argument to this data frame constructor. So the matrix and the column names. And it returns a data frame object. So second DF is a data frame object. And you could print the contents of the second data frame object, and that's what is getting printed here. So it's 11 row by 2 columns data frame, and then now the column names are assignments and exams. And since the values for each of those columns are decimals, Julia automatically assigns the data type of these two columns to be of type float 64. Okay, so now if you look at this data frame as well as the original source file, there's no IDs, like there's no way of identifying each row by a unique ID. So the person name is also missing. So let's create an IDs column. Now, let's make it simple that we'll be assigning the IDs like same as his row numbers, 1 to 11. So what we could do is we could generate an array using the collect method and pass 1 to n rows. So n rows is going to be 11. So 1 to 11, increment of 1 will be generated as an array. And now this is a way that you can add a column right away to the data frame. So right now the data frame has two columns, the assignments and exams. So at this point, what happens is when you call second df dot IDs, there's no IDs column as of now. But when you do this, when you call like this, and you are passing a vector, because each column is basically a vector of values in a data frame. So this is a vector of assignment values, and this is a vector. Exams is a column and its values are treated as a vector. So the IDs is going to be treated as a column, and it's going to be assigned this vector of values from 1 to 11. So if you print the second DF again, let's do that and see how it is going to appear. Um, okay, so this is where it printed initially. So now after adding this IDs column, it's going to get appended to the end of the data frame as the last column in the data frame. So that's how it is. So now what we may want to do is we may want to bring the IDs column to be the first column in this data frame. So the way we could do that is like this. So the select method is like the select method in SQL language. You could pass like there the table name. So here you could pass the data frame name and then what columns to retrieve from the data frame. So now the column names could be passed like this, a colon, and then the name of the column, if you're specifically referring to a particular column name. So you know IDs is the column name, so you could pass colon IDs. So we are going to select statement is going to be basically retrieving the contents of the data frame. So the second DF is a data frame we're looking at. I want to retrieve its content based on the IDs column, followed by the other columns. If you put comma and just a colon, every other column will also be retrieved in the same order. The columns are there in the data frame. So the other columns are like in the order of assignments first, followed by exams. So the IDs column will be retrieved first, and then the assignments column, and then the exams column. So you don't have to explicitly state all the other column names. You just want to bring the IDs column first, and then followed by everything else in the same order as it is. So what I'm going to do is whatever all the rows, so I'm not restricting any row to be not retrieved. I'm just selecting from this data frame all the IDs column and the other columns. So basically I'm asking for all the rows in the data frame. So the return value is assigned back to the second DF itself. So the second data frame, whatever it is currently it's going to be this order, assignments, exams, and IDs for this 11 rows, is going to be overwritten with the same 11 rows, but the IDs column will be appearing first and then assignments and exams. So that's how the uh, second data frame would be appearing now. So I'm printing here after including the IDs column and kind of moving it to the first column. This is how it looks like. Okay, so IDs and so let me do this here. So it should have been like this. After including the IDs column, it should appear like this. After moving the IDs column. Yeah. So let's keep going. Okay, the output is generated. All right. So yeah. So we are here. After moving the IDs column, it's like this. So now let's say you want to sort the contents of a data frame based on a particular column. So we could do that like this. So we could call the sort method, and you're going to again force the result of the sort on the data frame on which you're calling. So you put exclamation mark. So pass the data frame object name, and then pass the column based on which you want to sort the data frame. So now there is a kind of optional argument. So you can say comma reverse rev, yes, rev equals true. If you do that while calling the sort method, it's going to sort the data frame based on this column in the decreasing order of the value. So basically reverse order, okay, in the decreasing order of the values. If you don't pass this optional argument rev, it's going to sort the contents of the data frame based on its assignments column in the increasing order. So you could print in both formats if you want. And so again, you're enforcing that change. So if you make it appear in the decreasing order and put exclamation mark, so the first time it's going to be printing in increasing order. That's increasing order of the assignment scores. So the IDs, the values, and the exam scores will be automatically moving around with that. And then when you print in decreasing order, that is when you sort again in decreasing order by setting REV equals true, it's going to be appearing like this. So this is the decreasing order of the assignment scores. Okay. Now, so if you want to find now, say the average assignment score, you could do like this. So again, assignments is the column name, and you want to sum basically all the assignment scores. So again, like how you access a matrix, this is a comma, so it's like a row index, comma, column index. So now you put a colon to indicate all the rows, and this is the column name. So basically, you want to retrieve all the assignment scores of all the rows, and then sum them up. And that's going to be the sum of all the assignment scores. And you divide by n rows, the number of rows. So basically, you're taking the average of the assignment scores. Okay, so this is the syntax. You put like a comma separating the row and column index. And the row index is basically all the rows. So you indicate that by putting a colon. And the column index is basically that particular column, the assignments column. So you can retrieve all the rows in the assignments column, sum them up, and divide by the number of rows. That's the average assignment score. So I can print the average assignment score be something like this. Now, I want to be able to create two data frames, two sub data frames if you want to call. One data frame has records whose assignment scores are greater than or equal to the average assignment score. And the other data frame should have records whose assignment scores are strictly less than the average assignment score. So that's a very important method. So if you have a data frame and you want to now process some subset of those data frame, based on some criteria, extracted based on some criteria, we could do it like this. So you can call this add subset method. That's a method available in this data frames meta package. Okay, and pass the underlying data frame that you want to kind of use to get the subset. So again, the second data frame is still going to be there. It's not going to be lost or anything. It's just trying to get a subset of the second data frame, and the result will be now stored in a new data frame. So this is underlying data frame. And then you need to pass the condition based on which you want to extract that subset. The condition is now based on the scores of the assignments column, and you want to consider all the rows. So it's like a broadcast operator in which you want to consider all the rows for the assignments columns, use the dot. And as long as assignment scores are greater than or equal to, so assignment scores for each record or greater than or equal to the average assignment score, they'll be now put together in this data frame. So I call it as above average assignment data frame. Then the second data frame, another data frame I want to extract is on the same second data frame. I want to extract the rows for which assignment scores for each record you want to look at, and if it's less than the average, strictly less than the average assignment score, I want to extract those records and put them into this data frame, which I called as a below average assignment data frame. So now all I'm trying to do is printing them. So so this is the basically the final what do you call the order listing of the second data frame based on the decreasing order of the assignment scores. And we found the average assignment score to be 32.136. So when you're extracting the subset, it's going to extract in this order, whichever assignment records have assignment scores above or greater than equal to this average. So this 44.2, the first one is the first record in this above average assignment data frame. Then that is on 0.5, that is 0.7, 35.7, 33.9. Because since it's sorted in decreasing order, it will be in that order as well. And then the last 6 records where assignment scores are less than this average 32.1 will be in this here, the below average assignment score data frame 31.7, 30.9, and so on 20.4. Okay. So let's stop this video with this.